Today we're going to be going over Unit 2.2, which is standard form of a quadratic function. Starting off, standard form is written as ax squared plus bx plus c, where a, b, and c are all real numbers and a cannot equal to 0. You have to keep in mind a quadratic won't always be given in standard form. It might come in factored form or vertex form, so we'll need to rewrite it. And we could do this by using the box method. The box method is pretty straightforward, and all we're doing is multiplying x plus 3 times x minus 1. Here I'm just doing x times x, which is x squared, x times 3, which is 3x, negative 1 times x, which is negative 1x, and negative 1 times 3, which is negative 3. After this, we could just simplify our equation by combining like terms, and we get x squared plus 2x minus 3. And just like that, we have standard form where a is equal to 1, b is equal to 2, and c is equal to negative 3. We're going to start off our first example by identifying our coefficients, which we know is a is equal to 1, b equals to 4, and c is equal to 3. After this, we will find the vertex by using the formula x equals negative b divided by 2a, which in this case turns into negative 4 divided by 2 times 1, which would give us negative 2. Now all we're going to do is plug in negative 2 into the equation to find y. So in parentheses, I put negative 2 squared plus 4 parentheses negative 2 plus 3. And after multiplying, we get 4 minus 8 plus 3, which is equal to negative 1, which is our y. The axis of symmetry is the vertical line going through the vertex. So in this case, it would be x is equal to negative 2. The y-intercept is just c, so in this case, it would be 3. Now you can plot the vertex, the y-intercept, and use symmetry to reflect the y-intercept across the axis. Since a is equal to 1, the parabola opens up and has a normal width. Let's try one more. This one opens downwards. For this equation, our coefficients are a is equal to negative 1, b is equal to 8, and c is equal to negative 5. Now we're just going to find the vertex by using the formula we used last time. So in this case, the equation would be negative 8 divided by 2 times negative 2, and that would give us 2. Now plug x equals 2 back into the equation. So negative 2 times parentheses 2 squared plus 8 times 2 minus 5, which would give us negative 8 plus 16 minus 5, which would give us 3. So for this equation, our x and y would be 2 and 3. Our axis of symmetry would be x is equal to 2, and our y-intercept would be negative 5, which would give us the point 0 and negative 5. And now we graph. We're going to plot the vertex and the y-intercept, and since a is equal to negative 2, the parabola opens downwards and is narrower than the first one. Let's do one that's not in standard form yet. Say we have f of x is equal to 2 parentheses x minus 3 squared minus 4. This is in vertex form, but we can rewrite it in standard form by expanding. First, we can expand the squared part, so parentheses x minus 3 squared would equal x squared minus 6x plus 9. Now we could multiply by 2, which would give us 2x squared minus 12x plus 18. And after that, we could just subtract 4, which would give us 2x squared minus 12x plus 14, which would be our standard form. So now we know that our coefficients are a is equal to 2, b is equal to negative 12, and c is equal to 14. And we can graph or find the vertex from here. Reviewing what we learned, we now know that standard form is ax squared plus bx plus c. And we also know to find the vertex, we use the equation x is equal to negative b divided by 2a. The y-intercept is always c. And you could expand from factored or vertex form by distributing. We also know that a tells us if the graph opens up or down and how wide it is. Now try your best to apply what we've learned and try this one on your own.